boys and girls. It's Mrs. Gilreath. I am here to talk to you a little bit about word problems. So where we're going to start today is we're going to be talking about the cubed strategy. Okay, you might have seen this if you're in my class or Miss Creef's class. You might have seen this hanging up on our board and also in Miss Finn's possibly. But this is a kind of little helper sheet that we're going to use to try to kind of break apart word problems, make sure you understand them, make sure we're getting the correct information out, and making sure that we are solving the questions that they are asking us. So let's do a quick little overview. What does cubed mean? Okay, the C stands for, when you are looking at a word problem, we are going to be circling the key numbers or units. What do I know? So they're going to, any numbers or units that they put in the word problem, you're going to circle them, okay? Next, underline the question. What am I being asked to solve? And all of this is taking place before we even start to do anything with the word problem. We're going to circle the numbers and units, underline the question, box the action words. Am I going to add, subtract, multiply, or divide? Are there any words in the word problem that hint to me what operation I'm going to use? And then the E is evaluate and eliminate. What steps do I have to take, or what information do I not need? Is there anything extra in there they put to maybe try to trick us or fool us that we can go ahead and X out that doesn't have anything to do with the word problem? And last, the D in cubed means draw. And this is a really, really important part of solving word problems. Lots of times word problems, the math part isn't as hard, but it's all the information that you're given. And if you draw a picture, an array to help you understand the problem, that will really help. So circle the key numbers and units, underline the question, box any action words that tell us or give us a clue of what operation we're going to use, evaluate and eliminate. Is there anything we can take out? And then we're going to make sure that we draw a picture. Now we're going to make sure that we have this on your slideshow. So it will be on your slideshow for, I believe this is Wednesday for your work. So not to worry. Okay, now this is going to be a little bit of moving around. So please be patient. Okay, because I want to make sure that you can see each part of the word problem as we go. So here is the word problem we're going to be looking at and using our cubed strategies for. A scientist mixed 125 grams of chemical A with 626 grams of chemical B. How many more grams of chemicals does the scientist need to add to have a mixture with a total of 2,000 grams? Okay. That might be a little bit better to see with not so much light. Okay, so cube strategies. First thing we're going to do is we're going to circle any numbers or units, okay? So we're going to come over here and say 125 grams, 626 grams, okay? Any other numbers we see? And 2,000 grams. So this is just drawing our attention to circling any numbers or units. Now, we may circle grams, but when we read through, they might have actually, that might fall under another cubes strategy list. So let's hold off on that, okay? Now, underline the question. So let's make sure we're going to underline the question. Here we go. How many more grams of chemicals do the scientists need to add to have a mixture with a total of 2,000 grams? Okay, so how many more does the scientist need to add to have a mixture with a total of 2,000 grams? So we've done our C, we've circled, and we've underlined our question. Box any action words. So let's look and see. The scientists mixed 125 grams of chemicals with 625 grams of chemicals. Okay, nothing there that tells me other than mixed. So maybe we can put a box around mixed, because what do you do when you mix? You're going to be adding together. How many more? I might box that. That might give me a clue of what operation I need to do. That might tell me I need to subtract. Of chemicals does the scientist need to add to have a mixture with a total of 2,000 grams. So I'm just boxing the words that might give me clues. And in this problem, you actually have a couple of steps you need to do. All right, let's take out anything that we don't need. Okay, so I'm going to actually mark out grams because it really doesn't matter in this problem. And sometimes when you're doing a word problem, they might throw grams, ounces, pounds, and it really doesn't matter. It kind of gets in our brain and makes us a little bit confused sometimes. So that would kind of be an option if you wanted to take that out. But for me, I think I'm going to X those out and eliminate those. All right, and we're going to get to the draw picture part in a minute. So let's go ahead and break this word problem apart. What important information is given to us in the problem? So what are they telling us? Okay, let's look. They have told us that we have 125 grams of chemical A, and they have told me that we're going to mix it with 626 grams of chemical B. Okay, so I can kind of check those off. Now, when I'm mixing together, okay, and let's read on so we don't miss something. How many more chemicals does the scientist need to add to have a total of 2,000? So we've got to figure out, we also know that there is a total of 2,000. Okay, so that's just the information we know. Okay, what is the question that we are being asked to find? Okay, it says, how many more do we need to add? Okay, so we're going to say how many more. And when you're doing this, sometimes you can just, this is really for you so you don't forget. Okay, so you don't have to always use perfect sentences. This is more kind of like a workout sheet for you. And we know that it has to have a total of 2,000. Okay, so how many more? Okay, it's asking us how many more. If we add these chemicals together, how many more do we have to add to get the total of 2,000? All right, so when I know I have to, what do you have to solve? Okay, it looks like we're going to have to add our chemicals together, and then we're going to have to subtract to get how many more. So I would write my add and subtract here. That's my guess at this point anyway. So we'll see if we're right when we finish it out. Now, draw a picture that might help you to solve the problem. Okay, so really I would just do, maybe label it A, 125 grams, and B with 626. I know I have to add those together. Okay, and then I have my 2,000 here, and I'm going to subtract whatever I get from my 2,000, okay? Because I know they're asking me how many more do I have to add, okay? All right, so let's say, what did I do? What did I do? Explain in words what you did to solve the problem. So we're going to come back to that one, okay? So let's check off what we did so far. Cubes, okay? We know that we are using our cube strategy. So we're going to hold off on that for just a minute. Let's go ahead and look down here. We're going to actually solve the problem, okay? Solve the problem. We're going to use it right down here. We're going to solve the problem. So we know we have 626 plus 125. That's chemical A and B. Now that's A and that's B, but I like to put the larger number on top when I'm adding. Okay, doesn't matter. So let's add. 6 plus 5 is 11. Carry our 1 here. 2 plus 2 is 4, plus 1 is 5. And 6 plus 1 is 7. Okay, so I know when I add chemical A and B, I've got 751. So I can check off up here that I've added. Okay, and let's look at our problem again. They mix the chemicals. How many more does the scientist need to add to have a mixture with a total of 2,000? All right, so we've added. We know we have 751 grams. We have to get to 2,000. So So what are we going to do? Let's take away what we have. Okay, we know we have to get to 2,000, and we know that we already have 751. So let's subtract, and see how many more we have to add to have a total. Okay, so let's go ahead and subtract. This can be a little bit tricky. Oh my goodness, we've got lots of zeros. So let's go over to our 2. We know we cannot borrow from any of these. So let's go to our 2. I'm going to take it and change it to a 1. That's going to change this to a 10. You have to still keep going. So we're going to change that to a 9. Makes our next place value spot a 10. You have to keep going. Now we're in business. We've had to go across 3 zeros. So now let's subtract. 10 minus 1 is 9. 9 minus 5 is 4. 9 minus 7 is 2. And then we're going to carry down our 1. Now, that tells me that I need 1,249 more grams to add to my 751 that I already had, because we already mixed these chemicals and got 751. Okay. And I know I have to have a total of 2,000. So I subtracted what I had, and here is what I had left. All right, let's explain in words. And I'm going to kind of make this a little bit shorter because this is for me. First, we had to find out how much did we have. So I'm going to put F for first. How much did we have? How much did we have to begin with? So we added. We added our 125 and our 626. That's what we did first, okay? Remember, we added those together, okay? And next, N for next, we subtracted from 2,000. We subtracted from 2,000, which was our total, okay? Because we knew we needed to find the difference, okay? We knew what we had already, and we needed to subtract to find out how much more we needed, okay? And then finally, we got our answer. After we subtracted, we forgot our answer for how much more. Now, how do we know that our answer is correct? What is a check that you can do when you have subtraction? So what we would do, okay, is we could check our work backwards. We're going to add 1,249 plus our 751. And when we add that together, we get our 2,000. We get our 2,000, okay? You could come over here, maybe. We might leave a little bit more space next time and double check. 9 plus 1 is 10. 5 plus 4 is 9, plus 1 more is 10. 7 plus 2 is 9, plus 1 more is 10. Put our comma, and there is our 2,000. So we double checked by adding our 1,249 plus our 751, and we got our 2,000. Okay, let's look over here really quickly for our cube strategy. We did draw a picture, okay? We did kind of guess and check, okay? And we a little bit worked backwards. We really checked our work from what we had, okay? And we also used our cube strategies. Okay, so when we look at a word problem, let's make sure we answered it correctly. A scientist mixed 125 grams and 625 grams of chemical A and B. How many more does the scientist need to add to have a mixture with a total of 2,000? Okay, so if we check our work, we can do a check here to say we have worked it out. We have found the important information. We have asked, what is the question? We've done both of our operations. We drew a picture here. We did what we did first, next, and finally. And then we worked out our problem. Okay, so I'm going to show you the cube strategy one more time. Cubed strategy. So I hope this helps. In your small groups, we're going to be going over this with you. So we'll get to do some more practice, but I hope this helps for you to break down a word problem to understand the important parts just a little bit better. We'll talk to you soon.